Today we start our discussion with some important functions, which is first one is Peano's successor function. Peano's successor function is defined from set of positive integers to set of positive integers and is defined as sigma of n equals n plus 1. That is, if we input 1, we get 2. 1 plus 1 is 2. Also, if we input 2, we get 3. And if we input 3, we get 4, etc. Here the range set of this function is 2, 3, 4, etc. Next, we define floor function. F from R to R, f of x is a floor function. Floor function means greatest integer less than or equal to x. If we input 2.5, greatest integer less than 2.5 is 2. A number less than 2.5, an integer, the greatest integer less than 2.5 is 2. Minus 2.5, greatest integer less than minus 2.5. In the number line, between minus 2 and minus 3, minus 2.5. And an integer less than minus 2.5 is minus 3. So the answer here is minus 3. Next, ceiling function or roof function. G is a function from R to R. G of x is equal to, this roof function is the least integer greater than or equal to x. Least integer greater than or equal to x. Ceiling function of 3.3. Greatest integer, least integer which is greater than 3.3 is 4. Least integer which is greater than 5.5 is 6. Okay, and so on. Also, the ceiling function of minus 3.3. Minus, in between minus 3 and minus 4, we get minus 3.3. The least integer which is greater than minus 3.3 is minus 3. So, the ceiling function of minus 3.3 is minus 3. Now we define the restriction of a function. Let f from x to y be a function. F is a function from x to y and a is a subset of x. Then fa is a function. Here fa is a function from the set a to y. Okay, it's called a restriction of a if fa of a equal to f of a. That is, in the function fa, the elements in the set maps to f of a. That is, the elements, the images of the function f is same as the images of the function fa. Okay, then this function fa is the restriction of f. Also, if g is the restriction of f, then f is the extension of g. So here fa is the restriction of f, then f is the extension of f of a. For example, consider f from R to R be such that f of x equal to x square. And fn is the restriction because here fn is from n to R, n is a subset of R, n is the set of all natural numbers and R is the set of all real numbers, is such that f of n is equal to n square. That is, the natural numbers maps to its square. Here the first function is real numbers maps to its square and its restriction. Here natural numbers maps to its square. Okay. Also note that number of elements in the set x is equal to m and number of elements in the set y is equal to n. Then number of functions from x to y is n raised to m. That is, number of elements in y raised to number of elements in x. For example, consider the set x is equal to set a, b, c and y is equal to set 0, 1. Then list all the functions from x to y. List all the functions from x to y. The first function is f1. f1 equals set a0, b0, c0. It's a function. Every element in the set X has a unique image. f2 set a1, ordered pair a1, b1, c1. Okay. Next f3 set ordered pair a0, a, the only element a maps to 0, other elements maps to 1. And in f4 a maps to 1, b maps to 0 and c maps to 1. And in f5 a maps to 1, b maps to 1 and c maps to 0. Also f6 a maps to 1, b maps to 0 and c maps to 0. f7 a maps to 0, b maps to 1 and c maps to 0. Also f8 a maps to 0, b maps to 0 and c maps to 1. f1, f2, f3, f4, f5, f6, f7, f8. Here one is missing, a1, a0, b0. Okay. Okay, eight functions are there. Only 8 functions are here. We know that number of functions from x to y. Number of functions from x to y is number of elements in the y raised to number of elements in x. That is 2 cube. We have 8 functions from x to y. Now we consider factorial function. F from set of natural numbers to set of positive integers such that f of n is equal to n factorial. N factorial means the product from 1 to n for n greater than 0, and f of 0 is equal to 1. Factorial of 0 factorial is defined as 1. Next we define the composition of functions. One of the function operation is composition. If f from x to y and g from y to z, then g composition f. Here f is a function from x to y and g is a function from y to z. Then g composition f. G composition f is a function from x to z. So G composition f is a function from x to z. G composition f is defined as g of f of x. G of f of x. Here f of x is a function from x to y. So g of y, that g of y is z. Okay. Also, G composition f is defined as set of all ordered pair x z such that x element in x and z element in z. Also, there exists a y such that y is equal to f of x and z is equal to g of y. Okay. Next, we move to the problems of composition of functions. Now we discuss a problem. Let x is equal to set 1, 2, 3, y is equal to set a, b, z is equal to set p, q, r. And f is a function from x to y defined as f is equal to ordered pair 1b, 2b and 3a. And g is a function from y to z as g is equal to ordered pair a, r, b, q. G composition f is a function from x to z. Okay. So 1 related to b and b related to q. 1 related to b and b related to q. Therefore, there is a relation 1 q. Also 2 related to B and B related to Q. There is also a relation to Q. Also 3 related to A and A related to R. So 3R. This is G composition F. Now next problem, f from R to R and g from R to R are functions defined as f of x equal to x square minus 2 and g of x is equal to x plus 2. Then find g composition f and f composition g. It is g composition f. G composition f of x is defined as g of f of x. Here f of x is x square minus 2. And we know that g of x is equal to x plus 4. We replace x by x square minus 2, we get g of x square minus 2. So g of x square minus 2 is, we replace x by x square minus 2, that is x square minus 2 plus 4, that is equal to x square plus 2. So g composition f is x square plus 2. What is f composition g? F composition g of x is equal to f of g of x. That is equal to f of g of x is x plus 4. That is equal to f of x plus 4. We replace here this x by x plus 4. That is x plus 4 whole square minus 2. That is x square plus 8x plus 16 minus 2. That is equal to x square plus 8x plus 14. So the answer is x square plus 8x plus 14. Another problem. F of x equal to x plus 3. G of x is equal to x minus 4, h of x equal to 5x are functions from R to R. Then show that F composition G composition H equals F composition G composition H. That is, we have to prove that the operation composition is associative. So first we consider the left side, F composition G composition H. That is F composition G of H of x. That is equal to F of G of H of x. That is equal to F of G of H of x is 5x. That is equal to F of G of 5x. Here G of x is x minus 4. So G of 5x is 5x minus 4. Then what is f of 5x minus 4? We replace this x by 5x minus 4 plus 3. That is equal to 5x minus 1. So left side is 5x minus 1. Then what happened in the right side? F composition G of H. F composition G composition H. F composition G composition H is F composition G of H of x. Okay. That is equal to F composition G of H of x is 5x. Also F composition G is F of G of x. So F of G of 5x. That is F of G of 5x is 5x minus 4. So f of 5x minus 4 is 5x minus 4 plus 3. That is equal to 5x minus 1. From 1 and 2, it is clear that left side equal to right side. That is, F composition G composition H equals F composition G composition H. Or the operation composition is associative.